Hello and welcome to the Digga podcast, where we talk about everything to do with earth-moving attachments. Join Digga CEO Alan Wade, product specialist Anthony Weekman, and head of marketing Lionel Smitka for a blend of helpful information, interviews, and funny stories from the past 40 years.
Thank you for tuning in to another episode. Today we're going to talk about screw anchoring drives. And to do so, we're joined by a special guest straight out of Dyersville, Iowa. Bo Ellingson is sales manager in the US. And with the US selling screw anchor drives like we sell drilling drives in Australia, we thought it would be fitting to include Bo in this episode. Welcome to the podcast, Bo.
Hey, well, thanks for having me. I appreciate the opportunity to share some of my experiences and viewpoint from this side of the world.
Oh, it's great to have you. Before we get started, what's happening in the US? How's the economy? You guys flat out like the rest of us?
Yeah, well, I mean, I think the economy as a whole is on the rebound a bit. As for our purposes, our industry, really there wasn't much of a downturn, and fortunately for us, we haven't been negatively impacted by the COVID pandemic, and we were able to kind of continue to grow through it. Currently, the demand is still very high, and business is very good.
That's great to hear, and I see the US is getting back on track. Trade shows are happening, which is great to see.
Recently, actually went down to the World of Concrete trade show, and although the numbers weren't what they traditionally are as far as attendees and whatnot, it was good to get back seeing some customers that were able to make it and stop by the booth, and look forward to seeing everyone as we continue to go to trade shows and get back to some sort of normalcy.
What happens in Vegas stays in Vegas.
Well, I think we've had that show already.
I haven't. Okay, sorry.
Before we go too much further, you'll hear Bo mention helical piles, where Anthony and Alan will probably refer to them as screw piles. Bo might also refer to foot-pounds of torque, where in Australia we refer to it as Newton meters.
Aluminium and aluminum.
We may need to translate the podcast afterwards.
Pounds, Newton meters.
All right, let's get started. Anthony, what's a screw anchor drive and how does it differ from a drilling drive?
So the main difference, anything can screw a screw anchor in, and lots of guys think that they've got a drive and they'll drive an anchor in and walk away. But essentially, what really differentiates the auger drive to a screw anchor drive is the addition of our energy control valve. So that's it's protecting the drive from any kickback, and also you need to have a gearbox that is built to work at a constant high torque. Your drives, traditional auger drive will sporadically hit its peak each time, but a screw anchor drive is going to hit that peak and hold that peak for a long time while you're driving those screw anchors down 4, 5, 6 metres and up to 20 metres. So it's about how robust that drive is, and it's going to be able to handle that high torque consistently.
So you can't take a drilling drive and start putting anchors in. I presume the RPM won't work?
Yeah, guys will try and you can adjust it, but traditionally you want to be augering. You're going to be up around depending if you're in rock, clay, whatever you're drilling. But traditionally guys are going to be up around that 40, 45 to 50 RPM. If you're doing those sort of RPMs with a screw anchor, then you're going to just be augering that screw anchor in. Your revolutions are going to be going too quick, and you're just going to be cutting it in rather than screwing it in and anchoring it into the ground.
And don't fall into the trap of, if you've got a PD40, thinking you've got 40,000.
Yeah.
It doesn't work that way.
Many a business has been closed down and reset up.
Well, yeah. If Cole's listening, he bought a PD40 at auction and thought he had 40,000 Newton meters and started to screw anchors in.
Yeah. So, Bo, I think the US is well and truly advanced when it comes to screw anchoring. What applications are you seeing screw anchors or helical piles being used for?
Well, I mean, really, the applications are really endless. As far as residential foundation repair, remediation, decks, boardwalks. Oftentimes helicals can be used for tieback, slope stabilization, shoring, whether permanent or temporary. And certain electrical transmission lines, communication towers, things like that. And if you look at it, or you look out your window, really anything that requires a foundation, a helical pile, or some other form of alternative foundation is always an option. So obviously a lot of it may depend on the lay of the land and geotechnical factors, but yeah, I mean the applications for their uses are very broad.
We've seen a huge use in solar farm.
Yeah, that's massive now.
Yeah.
I don't think a solar farm goes in without a screw anchor these days. I don't think they do traditional peering with that. They want minimal ground disturbance. They don't want to get rid of all the spoil. They just want to go and punch it in. So the only drilling they sort of might do is a bit of pre-drilling if the ground's a bit hard.
How many piles went into that one in northern New South Wales at Moree or something, wasn't it? It was.
Yeah, that was. I can't remember off the top of my head. It's been too many beers since then.
Yeah. But it was in excess of like 30,000 piles or something.
It was huge. They ended up. I think they ended up running about 5 PD18s and a couple of 30s, PD30s that was done up. They had a heap of drives.
Yeah, there's another farm about to kick off, or I think it has kicked off in Western Queensland. Apparently that's going to look like a pimple on a pumpkin, compared in size. So.
Jason Moddy's running 3 or 4 SD drives that he's made on that mast, and he just punches those things in farm after farm.
Bo, are you guys seeing a lot of solar projects using helical piles?
Yes, yeah, we are, and yeah, you're right. Generally, when it is a solar project, I mean, it's a big project, tons of piles, multiple drives. I know that there must be a couple up for bid right now. I'm hearing some information on that, but yeah, that's a common application. Oil and gas is another big one. It seems that industry, it's a very common use for helical piles, whether that be on the substation, oil mats, the actual pipeline itself, storage, housing, the whole works. A lot of times, some sort of screwed in anchor is the preferred foundation.
But while you're talking about housing, it was interesting after Hurricane Sandy and Katrina went through, thousands of houses had to be lifted above flood levels. That was a massive time for Digga and I guess for helical piles. Yeah.
I mean, I went out after Sandy. I was out at New Jersey, close to the coast with a customer, and was able to see it firsthand. All the houses, a mile off the coast were all up on cribbing, and a lot of those were awaiting their helical pile foundation, timber pile, whatever it may be, but try to get to an elevation where they're less likely to be impacted by future natural disasters.
All right, so screw piling. What machines can you use to install a screw pile?
Well, I guess traditionally it was always the big guys that were 20 tonne and up were the screw anchor drive guys, but with the new trends of housing now getting screw anchors, we've got guys with 1.5 tonners wanting to do some kind of screw
mini
anchoring.
loaders.
Mini
loaders
They're doing
decks.
the shade sails, screwing in the anchors for those. So, that's what brought around the evolution of in Bo's world, it's the MM10K. We call it the MM14K here. So, it's a nice little tight compact drive unit that puts out 14,000 Newton metres of torque or 10,000 foot-pounds. It's allowing those guys with the smaller machines to be able to get in anchors nice and deep and at high torque.
Yeah, it's really
And I
good.
think that's appealing to, the contractors that are looking to get into, being an installer, or the client looking to have a job done, is the fact that, traditionally they can be done with much smaller machinery that's generally readily available to the contractors, than some alternative foundations.
There's a lot of in America. We don't see it in Australia because we don't traditionally have basements as such like they do in the US, and we developed a handheld unit for the US market, primarily because people physically carry these drive units down into the basement, and using a power source from outside the basement, i.e. an excavator or a skid steer or something like that, or a power pack, will be putting in screw anchors under floor, so under the floor of a residential structure. So really, these can be put for anything from you holding it by hand through to the biggest of excavators. I don't know what the biggest excavator you've put them on, Bo, but I've certainly seen them on things up to around the 60, 70 tonne.
Sure. Yeah. I mean, you get up into our XD range, the biggest range that we sell, the same models globally. You're looking at 60, 70 ton machines that's feasible to fit these two minimum 50 ton machines. So certainly, and to your point, the handheld market is it's still prevalent. I mean, if people need to get in these basement crawl spaces, elevator shafts, tough to reach and access areas, they're getting the job done with portable equipment that still gives you the ability to reach 5,000-6,000 foot-pounds of torque, which is, as you can imagine, be enough to hold on to. That's for sure.
We had Bo, you'll know, I think it was Magnum Peering. I can't remember who the customer was there, that they needed to get in underneath petroleum, inside a petroleum refinery, and needed to get in under pipelines that were still working. Up. Yeah.
Oh, that was the gimbal mount.
And we developed that gimbal mount for those guys, and they put it on. Was it a telehandler or a crane sort of setup?
Memory doesn't really serve what they had it on, but yeah, I do recall the application and just that need to keep the pickup of the machine really low and to have the basically the top of the motor of the drive unit essentially right underneath some racking, and we were able to come up with a solution with the jib extension. That was really one of the first ones we ever did. We've refined them a bit since, and most of our gimbal mounts are now kind of offered with 4-way swing, and we made some refinements. But yeah, that was a good example of kind of instead of just providing a product and not a full solution, working with the customer, and to kind of be able to tailor a product and a design specific to their needs and the application. So
yeah, we've always said we were able to solve a lot of most problems that customers come to us with. Miracles take a little longer, but we do our best.
Touching on mounts is a thing. I think a lot of the TPE, the telescopic extension for skid steers that we've developed, the MM10K, they've all come out of the US, where generally the rest of our product goes from Australia to the US. These have sort of flowed back because of the demand. So we're learning a lot from the US market and the jib extensions, or the boom extensions as we call them.
You got to, you have to be fortunate enough to travel to the different parts of the world. Certainly Bo's been out here to Australia, and likewise we've been over there to their market, and to understand that geographically Australia and the US are geographically the exact same size. It's just when you get down to population and population coverage across the country, the US have been smart enough to populate their whole country, where we tend to stick to the coast. for some reason we like water and sharks.
It's a great thing that I guess we're learning so much out of the world's biggest market and bringing all that we've learned back to Australia. So
you can see how mature their market is in the sense of, where our market still is traditionally excavators doing screw anchors and the odd guy with the mini loader. Not many guys are getting into it with the skid steers, yet over in the US, mate, most guys have got the TPE or
the sales of TPE in the US. I don't know exact numbers, Bo. You might be able to be clear on it, but they'll sell hundreds of units a year. We sell literally.
Yeah, I think we do like 100. I think we did like 120 to 30 last year or something like that.
Yeah, we do like one or two.
Yeah, just and a lot of them are used for drilling as well. A lot of people that want to use, drill 15 feet with a skid steer, and instead of having to, manually add and remove extensions, well, they're just, you get a telescopic piling extension, extend it, and you do the whole thing in one pass. But really, all that stuff, it's been good, but all of it's been really driven by feedback from the customers, and to our credit, we listened and designed something that we thought would be useful and reflective of what they were asking for. And generally when we do that, with the gimbal mounts that we sell a lot of on the MM10s, and now we have that available up through the SD range, jib extensions, telescopic piling extensions. It does set us apart, and then the ability to throw the complete package with the drive adapters in the mix, and ultimately it makes the our dealers' lives a lot easier, and ultimately the end user, whoever's going to be using that equipment, it makes their life a lot easier.
All right, we might move on to specifics of our drive and what sets our drive apart, and why it's probably the preferred drive in the industry. We might start with you, Alan. We make our own gearbox, and obviously that's going to be an advantage.
Oh, definitely, 100%. We have the total control over what's going into that gearbox, right from the design stage through to machining, case hardening, and whatever, and then to the actual assembly and build of the gearbox. If I go back to when and I'm going back probably 15 years, when our biggest gearbox was a PD50, and PD50 is 38,000 newton metres. Bo can do the conversion to foot pounds, but it's 38,000 newton metres. But we know its maximum that bottom gear set Series 8 will see is about 45,000 newton metres. If someone's going to be screwing helical poles, screw poles, and they're wanting to do it at 40,000, we knew that we had to come up with something better than that. Even though we know that one's rated 42, 45, if you're going to be going constant to 40,000 newton metres all day, every day, we needed something bigger and better to go beyond that. Hence, without giving too much away, the Series 8 is the bottom end of a PD50. We've then developed Series 9.5, and so on and so on. And we progressively did that right through the range to where we're now at Series 14. For a gearbox, it puts out 500,000 newton metres. That's, put that in perspective, that's 50 tonne of rotational torque at the shaft. Now, that's a huge amount of power.
It's a huge gearbox. It weighs a tonne. It's absolutely massive. Yeah. It stands taller than a person.
It's taller than most people. Yeah.
Right.
And and as we said before, you can that type of drive. Minimum, you want to be looking at is a 45 tonner, but we would say 45 through to 60 tonne. I think we sold most of the 500s that we've manufactured all manufactured in Australia, have been sold into Canada. Is that correct, Bo? Most of I think there's about 8 in Canada.
A lot of the early ones we do have a few 3.4, I believe, in the States as well. And it seems that the inquiries in that range have picked up a little bit, domestically here in the U.S.
Yeah, we're actually starting to get. I think
There's a few jobs that are calling for that sort of range. I don't know if they've come through yet, but there's been a couple of quotes.
That's not a high. There's very few. Like the pile that would be screwing in is massive. What's the pipe size on a pile like that? About 36 inch. I think the pipe is.
Definitely I've heard of some like big 24 inches with big massive triple helixes and things of that nature. But I think to a certain extent too, the requirement for that torque kind of has to do with the lay of the land, stability of the land as well. So I do feel it may be a bit regional depending on the geotechnical factors, but. I think I recall one project where it was being used on a 24-inch OD pile with 3 big massive helixes on them.
Now, another advantage of making our own gearbox is how compact the gearbox is compared to what else is out on the market.
Yeah, and look, again, we make the box as compact as we can, choosing our gearbox the way we build the gearbox, and also the motor that we choose to put on top.
Yeah, how that interfaces with the gearbox is part of our selection.
Yeah, we're currently using, and we favour the radial piston motor. Pure efficiency of radial piston is just way, to us, is way superior. And
handles that
and
high
it's compact.
horsepower.
And it's compact. It's compact in, probably more important is the compact in height of the overall drive, because that's where you're hanging one of these units under an excavator boom, and it's how much pile can I get in the ground without needing extensions. It's a critical thing for these guys, and that's hence why we came up with the gimbal mount. That was to increase it, and I think picked up at probably another. Look, maybe 5 feet, 1,500 mil of height just by going to gimbal on a standard drive. Yeah, so that's a big,
just gets them over the top of that pile.
So keeping them compact is important to us. We've been able to build a very, very strong gearbox in a very minimal space.
Well, to give that a bit of context, you have a story about someone in Canada looking over a fence.
Screw piling in Canada, because of the oil pipelines and that up there is common. And we had a good customer up there who probably took a punt on us early in the piece. These guys go out drive out over the frozen ground. This is in the North American winter. And they'll drive out over the frozen grounds, which is like through summer is just marsh. It's just bog, but the ground's frozen, so they can get across these grounds. So they'll go out and they'll screw piles in, stick saddles on the piles, and lay a pipeline. And they'll lay that from up Alaska way, like up the very northern parts of Alberta, and they'll lay that pipeline, and they'll be pumping oil down into the refineries. I think they're in North America, aren't they? Bo, they're in sort of Texas and around there, the big refineries. And they'll go out and screw these things into the ground all through winter. And the story goes that this one customer, the one that took the punt on us, he was sending trucks out with piles and all day, every day, and rarely, was a drive unit coming back broken, service, repair, whatever. His over the fence neighbour, and I'm talking, this is a big industrial sites. He's sending trucks out. They're doing the same type of work. Well, he's sending trucks out all day, every day, just like old mate over the fence. But what he didn't see was trucks coming back with drive units on them for repair. And up there, they like to have, if they've got a drive unit in the field, they'll have a drive unit in the workshop. And this guy was just seeing his mates, his neighbours' trucks going out with poles, coming back empty, going out with poles. His trucks going out with poles, come back with a drive unit. Service, repair, fix, send it back out, come back with a drive unit. And he eventually stood on a 44-gallon drum with his binoculars and looked over the fence to see what were these drive units. And
What brand it was.
What brand it was, and picked up our name. And that's the business up there has grown. We've got a very good reputation with the big market up there. And Bo, I've been up into Canada with Bo, especially into Alberta. It's a big region there for us, and we've done a couple of trips up there and to visit all these guys. And it's a world. It's a different world. They're a breed of their own. They've got $100 bills, just falling out of their pockets. They're all driving around in the biggest of Ford Raptors and whatever. It's certainly a different game.
We touched on radial piston motor just earlier. Ant, why is that our preferred motor?
Just through the efficiency of that motor, and as Al said, they're nice and compact for what they put out. The size of them and the power that they put out is phenomenal. So, over many years of development of screw anchor drives, where we've tried numbers and multiple numbers of different types of motors and all that sort of thing, and it was always our Achilles heel. That was, the gearbox would handle that duty cycle, but the motors didn't. The motors just didn't hold up to that, the rigours of screw anchoring, where you're just working at 90 to 95% of its capacity all day, every day. So, with when we got into the size, then they just handle that. They're well within their capacity of what they can handle, and they held. They're able to handle that high horsepower. So the combination of the flow and the pressure together, they just hold it in really well, and the efficiency is fantastic.
To put efficiencies into sort of layman is like you have a gear motor, very agricultural motor. You have a Girola motor, which is what we most commonly use in our day-to-day drilling motors, and then you have something like a radial piston. And, a gear motor will start up 90% efficient, but quickly, you run that solid for an hour, 2 hours, 3 hours, it progressively goes down, 90%, 70%, 50%. Gear motor is a very agricultural motor and does, tend to drop off fairly quickly. Girola motor starts up at 95%, and after an hour's solid work, it's probably still running about 80%. A radial piston motor, it'll actually start up around the 90% mark, but it actually increases efficiency. So after an hour's running, it's running at 95%. After more constant, it basically goes up to 100% efficient, because the actual internal workings of the motor, where oil's getting hotter and viscosity is going down, so you lose efficiency. The radial piston sort of takes up for that, because it basically, I don't know how you simply say it expands. Yeah. The ceiling in it expands, and is still able to use up all the power that's in that oil. Yeah.
Our screw anchor drives feature an ECV valve, or an energy control valve. Bo, did you want to touch on why we fit that valve and what it does?
Yeah, certainly. And, Anthony touched on this a bit earlier in the discussion. But certainly when, and it's not just for, installing a helical pile. I think that the benefits of the ECV energy control relief valve can also be realized in other applications, whether it be a grouted displacement pile, or a CFA that's pretty long, and you kind of get a similar effect with that. But essentially, when you are installing a screw anchor or a helical pile, oftentimes those are designed engineered to be installed to a certain torque. And in doing so, and or a depth, but nonetheless, there's a built-up rotational energy that's stored in that pile, and when you go to release your pressures, it'll momentarily kick back, and forces energy all the way up through the pile, drive shaft, gearbox, up into the hydraulic motor, and that action effectively turns the motor into a high-speed pump. Generating cavitation of the motor, and it leads to failure and expensive replacement cost, so on and so forth. So, I mean, essentially fitting our ECV affords you that protection where you're going to, when you go to release from the pile, that valve controls the release of all that built up rotational energy. And it'll ensure that your hydraulic motor and gearbox are able to be put to work for a good long while and live a good life. So it is very important. We do require it on all of our drives used for a screw anchoring application over 12,000 foot-pounds. We had some feedback on the lighter load helicals, small shaft diameter where, hey, look, at certain depths, we're just not seeing this. So we do allow some units to be sold for that application, lower torque without the ECV valve, but it does come at a lesser warranty because, you're not opting for that extra protection. I see it even with, particularly with square shaft piles. When you go see those installed, they're actually, traditionally installed to permanent yield deformation. So you can about imagine how much, rotational energy is stored in that pile when they go to release their pressures.
That's it. Yeah, a lot of times people ask, when do I need to add it? What drive? And my common answer is, you don't need it until you need it. It's like insurance. It's always too late after you've got that backlash and you damage the motor. So if you're going to be screw anchoring, you just put a ECV on and have peace of mind that your unit and your investment is protected.
Yeah. You got to remember that the hydraulic motor is running through the gearbox, and the gearbox is basic. It's a reduction gearbox, and just for these, if you've got a gearbox with a reduction of 200 to 1, and you're screwing an anchor into the ground, and it's 20 feet under the ground, it's 6 metres down. The helical at the bottom of that screw anchor has reached its maximum yield. It can't turn anymore. But the pipe, the flex in the pipe still will turn. And over that 20 feet, that pipe might turn a quarter, a half a turn, like a half a twist. Hasn't yielded, it's just a twist in the pipe. Well, it's when you realise when that pipe at the top stops and you disengage the hydraulics, the flick back in that pipe is now become 200 to 1 multiplication back up into the motor. That's where the damage is caused. And actually, the I don't know the right word for use for it, but the repercussion is not only the motor that's spinning backwards at 200 to 1, it's also sending that oil back down to the machine, to your valve. It's
like a bullet travelling through the system.
Just like a bullet. Yeah, it can do a lot of damage, and hence why we came up with it. And look, it wasn't something we just dreamed up as an add-on. It came from pure necessity and watching over the years guys, and a lot of it was in my day in Sydney, where guys were installing piles, and then they were bringing their drive units in to me saying, the motor's making all this funny swishing sound. And it turned out that the little pressure valves in the tops of the Eden motors were mushrooms, and was just allowing the oil to bypass, and that was this swishing sound, was this bypass. And we were just replacing those things, so much so guys were having replacement motors, and when that started happening, they'd take the motor off, put a new motor on, send that motor into us to get repaired, whatever. And we just sat down and said, why is this happening? Went out and actually physically watched it, and watched these piles screwing and then flicking back. And I tell you, when they flick back, this was on a PD40 or PD50, this particular case, when it flicked back with a bang. I thought the whole excavator was falling apart. I hit the ground. I was laying on the ground. The operator's just looking at me laughing. And I said, what was that? And he goes, it's the pole just flicking back. And then, penny dropped. Okay, you need to fix this. And, when we developed the ECV, and that's very, energy control valve.
Swoosh.
We originally, for years, it was called the swoosh valve because that's the noise that it made when it was activating. It just made this little swoosh.
It's not very descriptive, but it worked.
People knew what we're talking about.
All right, so a lot of our listeners may not know a great deal about screw anchoring or screw piles. What's the process? I'm guessing that it starts with an engineer choosing screw pile over traditional concrete foundations. Is that how it starts?
No, he's going to be best because he would be doing more of this day in, day out.
Yeah, I would say absolutely. It comes down to the design of the job, and it's the engineer who then decides whether it's going to be drilled wall holes with concrete and reinforcing, or whether it's screw anchor, and then he's got to then decide how much load that pile's going to take. So it's all in the design of how big that helix is going to be for the load, and then gives it. And that's what a lot of guys come to us when we're asking what rotation or torque they need to achieve. They'll give us that load rating of the actual pile weight. So they'll go, I need 50,000 kilonewtons, but that's the actual rating of the pile, not the install torque. So,
all right. So we're not going to get into the geotechnical side of things because that's not our expertise. But Bo, what's the process of choosing the right screw anchor drive for a customer?
Yeah, well, certainly, most times, by the time the customer gets to really looking into the installation equipment and what he's going to need for a specific project, by that time, if they have an engineered foundation and or are working with a, reputable helical pile manufacturer, so on and so forth, they'll generally have, an understanding of what helical pile is being spec'd and what the required installation torque is for that project. And it's not necessarily, the max torque for that helical pile, but generally they'll have a required installation torque. And to kind of extremely simplify it, it's generally, hey, they have a load of whatever that's the helicals are going to be supporting. And then, however conservative or aggressive they want to be, there's a safety factor. So you multiple of the safety factor by the load and you get your ultimate capacity. Well, each helical pile has a torque to capacity ratio. So if you take your ultimate and divide it by your torque to capacity ratio for that pile, that'll get you around your required installation torque. And that all happens, with involvement of a lot of other people and information, but generally that's they have that when coming to us. So with anchor installation and helical pile installation, torque is king. If you need the torque, you need the torque. So from that point on, really we're just making sure that for one, you have the proper machine spec'd out for that drive head. And make sure that you're able to achieve the torques you need to achieve with that machine, the pressures that are available from that machine, and at the same time making sure that you're going to be able to be happy and be able to live with the speeds you're going to get with the flow on that machine. So really a lot of it on our end is just, hey, look, making sure you have the torque and then making sure that it's a feasible fit to your machine. And from that point, we can make it real easy on you, but putting together a complete package quote with the mounting and plumbing and, any drive tool adapters you may need to connect to the pile, any torque measurement systems, you may need to either monitor or record, monitor and record your installation torques. Yeah, that's essentially, and oftentimes we do get the calls from people saying, hey, look, I have a skid steer or an 8-ton mini excavator and I want to get into this, quote me a drive. And I say, well, what sort of projects are you looking to take on? And, do you have a project? No, but I just want to start installing screw piles. And I'm
give me
very
the biggest one you got. That's usually
Yeah, right. But I'm very forthright in saying, hey, look, you need to start the process. Oftentimes, refer them to a reputable pile manufacturer that we do business with, and say, hey, look, when you get all your information sorted out, come back to me, and we'll get you sorted, because all I can really do at the moment is give you a range of drives that are feasible to use on the machine you have, but I can't guarantee that that's going to be right for the jobs you're looking to line up. So yeah, sometimes people go about it a little bit backwards. Oftentimes, even if I don't know the installation, what they need for a specific application, if I know what helical pile they're using, what the max torque rating is of that pile, even if we just know what needs to be installed, we've seen enough instances, and sold enough of these where we can kind of put them in a torque range just based on that information as well. But obviously, always preferred on my end to have a required torque that they know up front, and that we know we need to supply them a drive that can achieve that.
All right, so the customer comes to you and says, I need a drive that'll put a screw anchor for 100,000 foot-pounds. What are some of the ways that he can measure that to make sure that he's achieved it?
Sure. We have a few different systems. The most basic of which is a pretty simple adjustable inline pressure relief valve. It's fit in line between your hydraulic source and the drive head. There's a dial gauge on one side reading the supply, and another side reading the return. And that's a good system because you can manually work out your differential pressure, right? The supply minus the return. That's the operating pressure. That's what's being converted to torque. And then you correlate that to a torque chart, the respective torque chart for whatever drive you have. One of the beauties of that system is it also allows you to bypass pressure before the head. So let's say you have a 20,000 foot-pound head that are putting in a 2 7/8 or 3-inch pile that's rated to lesser torques. You can actually, if you know what torque you need, you can actually look at the torque chart and say, okay, I achieved that at 1,800 psi, and you can wind the relief out such that it will relieve when you achieve that pressure. So in essence, it gives you the ability to bypass pressure before the head to protect your steel in those instances. So that's the most inexpensive, also the most manual of the systems. We have an electronic differential pressure gauge that is able to be fit to really drives we sell worldwide. And it's electronic pressure reading transducers plumbed right in at the motor. That in real time you get differential pressure on a digital display in cab, and again you correlate that right to the torque chart and have a good estimation of where you're at. And the most sophisticated and expensive of them all is the calibrated torque measurement. It seems that the industry's moving towards calibrated torque measurement. Obviously, everybody has a vested interest in knowing that pile is installed to the torque that it needs to be installed to. With these systems, we have a couple different systems now. A torque hub that actually sleeves over the shaft of the drive, the output shaft, or a torque spool that is kind of flange to flange and fit in between, and you have to connect to with a steel fabricated adapter. But essentially, these systems are great because it leaves the guesswork out of it. You know that the torque reading you're getting is a calibrated actual torque measurement. All of the data is recorded. It's able to be exported to your email, downloaded via USB, and then the software is pretty user friendly as well, where you can graph this information, print it off, have the project managers, engineers of record sign off on it, and away you go. So it to a certain level gives that installer, another tool in his bag, and another level of accountability when bidding on projects and so on and so forth.
All right, just moving on to Australia, I think we find that there's a slightly different system in the US where pile manufacturers will have their own schools or learning centres, and they train new installers how to install piles. They'll sell them the drive, they'll sell them the piles, and set them on their way to a brand new business. That model hasn't come out in Australia and so on. Alan, do you see that as a likely?
It's heading that way.
It's heading that way, but it's different. It's in the US, there's these you mentioned pole manufacturers that actually do everything. They manufacture the pole, they engineer the pole, they have direct contact with foundation engineers. With someone doing a job will actually contact these people direct, and these particular organisations will have all across the US will have certified pile installers of their particular pile. Here in Australia, we've got pile manufacturers, and then we have installers. They
sort of set up like a subcontractor and give them a brief training and how to do it, but they're not sort of tied together.
They're not tied together. It's different, and there's a lot of differences between the US and Australia and the markets and whatever. But I do see it coming, and it slowly is. And I think down in our southern states, Victoria, around there, I'm seeing it more come into that way, as opposed to
Victoria's probably the most mature market for screw anchor now, isn't it?
100%.
I mean, once it was a Queensland thing when piling first came out, and the screw piling, but it's boomed down in Vic.
I just feel that we need more of that education process, but not just at installer level, but we need more engineers to choose screw anchors over traditional concrete foundations.
Look, in the US, they have there's engineers over there who've, if you think about it, they've dedicated their life learning to screw piles and the whole concept, and it's not a new thing. It goes back to the 1800s or something. It's like nothing that's happened just this.
Well, what I see over here is like to the credit of the helical pile manufacturers, the major players in that realm. We all have to compete with somebody, but at the end of the day, I think that they do. I'm on the other end of it, but I think they do a good job of kind of banding together to promote the technology as a whole. And we see that at a lot of we go to all the DFI, Deep Foundation Institute, their conferences and Superpile, the annual show, whatnot, and there's a lot of these breakout sessions, and it's major pile manufacturer A, B, and C are all kind of banded together to promote the technology, and these are the shows a lot of engineers, a lot of and so on and so forth, heavily geared towards college students, things of that nature, where they go to learn, and so I do feel that they've done a real good job of promoting the technology and kind of all banding together to do so. But to touch on the training and whatnot, and also as they're bringing in new clients and whatnot, they're making sure that the training is there for them, and that they're certified to install the product, and that's pretty commonplace with really anyone that we've worked with thus far.
And Bo and myself, we actually went and did one of the courses over there with one of the bigger players in the market there, and they're really well run. The lecturers give, what they're teaching you is really well taken. That what the literature they give you to understand is quite good. And I think it was a 2-day course, wasn't it, Bo, or something we sat through, and at the end of it, you got to, you had to sit a little sort of test at the end. But if you've been listening for the 2 days, no one failed. But you got a certificate to say that you had sat through this course, and just like doing a little TAFE course here in Australia, it was quite good. And if we could see something like that in Australia, I think screw piles would be, we'd see more of it here. I think people just don't understand them here. A lot of people just think they're it's a helix welded onto the end of a pipe. And how many guys do we know that have tried to make their own screw piles to save $1, and all they're using is an auger flight, a square pitch auger flight, and
augering it in instead of screwing it in.
It just doesn't work.
No, I guess with Australia coming on and pushing towards screw piles, Digga's in a good position with everything that we've learnt from the overseas market.
Oh, 100%. Yep.
So we might leave it there for this episode. We hope that everybody got something out of the episode. But before we go, we received some great feedback after the last episode. Mitchell Davies has suggested that we bring more structure into the episode.
Yeah, I've got Mitchell on some of my other social media sites, and I don't think you'll ever please this guy.
No. So anyway,
Perpetual whinger.
Look out for new segments in the new episode, new and improved podcast, hopefully. Bo, we thank you for joining us. Thank you for sharing your knowledge with us.
Yeah, appreciate you having me. It's been fun.
All right, bye for now.
See you, Bob.
Bye.
Thank you. See you guys.
Before we go, if you have a question regarding this podcast or a topic suggestion for a future podcast, let us know by emailing podcast@digga.com. We'll try to answer your questions in an upcoming episode. If you enjoyed this episode of the Digga podcast, don't forget to subscribe or follow so you don't miss the next one. And leave us a 5-star review while you're there. And also don't forget to tell your friends about it. Remember, you can follow us on Facebook, LinkedIn, Instagram, and through our website digga.com. Thanks for listening.